Hi class, here's our video lesson on 8.5. We're talking about three different quadrilaterals today: rhombi, squares, and kites. Let's define each of those three right away. A rhombus is a parallelogram, so it contains all the 6 properties of parallelograms. The more specific that we're going to get here is that it also has 4 congruent sides. So a rhombus, a parallelogram, and all 4 sides are the exact same length. So if one side is, let's say, 32 centimeters, then all 4 sides are 32 centimeters. So there's a rhombus. A square, you guys have probably heard this at a very young age. A square has 4 congruent sides, and it has 4 right angles. So another parallelogram, so it contains all the 6 properties of parallelograms. If you remember, the rectangle has 4 right angles, and the rhombus has 4 congruent sides. So a square is really a mixture of a rhombus and a rectangle. It's even a more specific type of rhombus and a more specific type of rectangle. It has 4 congruent sides and the 4 right angles. So there's our square. And then the kite. The kite is not a parallelogram. We've been talking about parallelograms for the past 3 or 4 days. Now the kite, we're getting to a quadrilateral that is not a parallelogram. It has 2 distinct pairs of adjacent congruent sides. So a parallelogram is like opposite sides are congruent. A kite, that's not the case. The adjacent sides, so the sides right next to each other, are congruent. So as you can see with this figure up here, this side is congruent to this side. They're adjacent. They're not opposite sides. They're adjacent sides next to each other. And this side is congruent to this side. If you remember flying a kite when you were a little kid, it probably looked something like this, where these 2 were maybe a little bit shorter, and then these 2 were a little bit longer, but they're congruent. So there's our kite. Right? Okay. So now we're going to be talking about more properties about these 3 shapes. Here's the rhombus first. In a rhombus, the hypothesis, if a parallelogram is a rhombus, our conclusion for this if-then statement is that each diagonal bisects a pair of opposite angles. So let's say this angle right here is 70 degrees. Okay? If that's 70, the diagonal is a bisector, an angle bisector, so each angle is now 35 degrees. Okay? Same thing here with the other diagonal. If this is 130 degrees, then it would cut the angle in half. Each one would be 65 degrees. Okay? So the longer and shorter diagonals are both angle bisectors. And not only are they angle bisectors, I'm on to a different property. This one, the diagonals are also perpendicular. So when they intersect, their intersection is a 90-degree angle, as you can see right here. This is an important part of a rhombus, because if I want to prove if something is a rhombus, I could find the slope of this line. Let's say the slope of that one is down 2 over 3. And if I find the slope of this line, and this slope, let's say, is a rise of 3, run of 2, well, now these slopes are perpendicular. They're opposite reciprocal slopes. So to prove if something is a rhombus, we would have to find the slopes of the diagonals, compare them, and see if they're perpendicular, because a rhombus will always have perpendicular diagonals. Another property here is the converse. If a parallelogram is a rhombus, then the diagonals are perpendicular. So now we would say if the diagonals are perpendicular, then the figure is a rhombus. So that's what we're going to have right here. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. And that is a true statement. Again, that's how we're going to prove if a parallelogram is a rhombus, is we're going to find the slopes of the diagonals and see if they're opposite reciprocals. Now a few properties about a kite. If a quadrilateral is a kite, then the diagonal is a bisector. The longer diagonal is a bisector. So if this segment right here is 20 inches long, then each side is 10. The longer diagonal is a segment bisector. Not only is it a segment bisector, but we also find that the longer diagonal is also an angle bisector. The longer diagonal bisects a pair of opposite angles. So if this angle right over here is 60 degrees, then each one is 30. Each half of the angle is 30. Okay? So the longer diagonal in a kite is a segment bisector. For the shorter diagonal, it's also an angle bisector. Okay, and one more property, very similar to the rhombus. In a rhombus, the diagonals are perpendicular. Same thing in a kite. In a kite, the diagonals are also perpendicular, so it makes this 90-degree angle right here. Okay, so now that we have talked about several properties, we want to ask ourselves a question. What are we looking at here when I graph this parallelogram ACBD? Let's first graph it and see what we're looking at. A is left 2, down 1. B is right 3, up 2. C is left 1, up 3. And D is right 2, down 2. So if I graph this, now graphing it is not enough, okay, but right now we can kind of get a little bit of a look at as far as what shape this is. It does tell us that it's a parallelogram. Okay, so we don't have to prove it's a parallelogram. The problem tells us that it is. So we want to find out what kind of a parallelogram. The three that we've talked about are rectangle, rhombus, and square. So is it one of those three or a combination of a couple? Or it could be all three. So if we want to see, let's just go first. If it's a rectangle, we can do one of two things. We could say that the slopes are perpendicular, and we could say that the diagonals are congruent. Those are two things that we know are true of all rectangles. The slopes are perpendicular and the diagonals are congruent. So we could find the slopes of all four sides, or we could find the distance of two diagonals. So we can do either one. I'm going to do the distance formula 2 times to find the distance of the diagonals. If they're congruent, we have ourselves a rectangle. So let's find the distance from A to B. That's one diagonal. So here is the distance from A to B. It equals the square root of x2 minus x1, 3 minus a minus 2, quantity squared, plus y2 minus y1, 2 minus a minus 1, that quantity squared. So we have 2 plus 3 is 5, squared is 25. 2 plus 1 is 3, 3 squared is 9. So we get the square root of 34 units. If CD is also the same length, then we have ourselves a rectangle. So let's find the distance between point C and point D. The distance from C to D equals the square root of 2 minus a minus 1, because that's x2 minus x1, plus y2 minus y1, negative 2 minus 3, that quantity squared. 2 plus 1 is 3, and 3 squared is 9, plus negative 2 minus 3 is a negative 5. Negative 5 squared is a positive 25. So the square root of 9 plus 25 is the square root of 34. What do you notice, class? The distances are congruent for the diagonals. If the diagonals are a congruent distance, now we can say this thing is a rectangle. This figure is a rectangle. That doesn't mean it's a rhombus, it doesn't mean it's a square, but we at least know that it's a rectangle. All right, now that we know it's a rectangle, let's see if this thing is a rhombus. A rhombus, the main way we're going to prove it's a rhombus is that the diagonals are perpendicular. So let's find the slope from A to B, and let's find the slope from C to D, and if they are opposite reciprocals, then we have ourselves a rhombus. So I'm just going to erase the distance formula here. We're now going to find the slope from A to B. So the slope is y2 minus y1 over x2 minus x1. y2 minus y1, 2 minus minus 1 over x2 minus x1. The slope from A to B is 3/5. Rise of 3, run of 5. Let's find out about the slope from C to D, and let's see if it's an opposite reciprocal slope. So from C to D, y2 minus y1, negative 2, subtract 3, over x2 minus x1, 2 minus a minus 1. Negative 2 minus 3 is a negative 5. 2 minus a minus 1 is 3. In class, what do you notice about these slopes? They are opposite reciprocal. If they're opposite reciprocal, they're perpendicular. And if they're perpendicular, that means we have ourselves a rhombus. So this shape up here, this parallelogram, is a rectangle and it's a rhombus. Now class, if it's a rectangle, that means all of these angles are 90 degrees, because a rectangle has 4 90-degree angles. And if it's a rhombus, that means all 4 of these sides are congruent. So if all 4 sides are congruent and all angles are 90, what else do we have? Yes, we have ourselves a square as well, don't we? Whenever a figure is a rectangle and a rhombus, it's automatically also a square. So this parallelogram is all 3, rectangle, rhombus, and square. Let me know if you have any questions on that when you get to class tomorrow.